Okay, number 5 is the next one that I'm going to do for you. Here we know this is a triangle problem because we have not values that are not on the unit circle here, negative 1/3 and negative radical 21 over 5. We are going to, this is a triangle problem. So we're going to draw these triangles and then we're going to find cosine of A minus B. So before I draw those triangles, I'm going to figure out what I need to plug into this formula. That way I don't need to do more, I don't do more work than I need to. And I'm just going to write it as A minus B instead of alpha minus beta. So I'm going to have, I need cosine of A times cosine of B plus sine of A, sine of B. Just from our equation sheet. That's how that equation works. Okay, let's work our triangles. I'll color code here for you. Oh, and I need to be careful about what quadrant we're in. We're not all first quadrant on this problem. So for triangle A, again, read that out loud to yourself, not from left to right, just the way it looks. A is between pi over 2 and pi. So that's second quadrant. So that's a second quadrant triangle that I'm working with there. So let's draw it. Cosine, if you have cosine, you're given adjacent over hypotenuse. Remember, we're always going to let our hypotenuse be positive. And then you can do Pythagorean theorem here. Go ahead and pause and find that missing side for yourself. So you should have gotten a squared as 8. And if we make that into nice simplified radical form, we can break down 8 into 4 and 2 and take the square root of 4. So it's going to be 2 radical 2. So if you want to write out your sine and cosine, because that's what you need to put in your formula over there, sine of A here is opposite over hypotenuse, 2 radical 2 over 3. And since we're in that second quadrant, sine is positive. And cosine we were given, but I'm going to write it here so when I'm looking over at what to put in my formula, I have it all together. If you want to enter those values right now, you absolutely can. Oops, sorry, that should be under sine of A. So, good start. Now we need to deal with our B triangle. So our B triangle here is between pi and 3 pi over 2. So I'm doing quadrant 3. I'm going to go ahead and forecast both of mine, both sine and cosine are going to be negative. So sine is negative radical 21 over 5. So my opposite is negative square root of 21. My hypotenuse is 5. I need cosine of B here, and this is my B triangle. I just didn't label my A triangle over here. My adjacent leg is going to be negative here. Go ahead and pause and do that Pythagorean, work through the Pythagorean theorem to find your missing side there. So you should have gotten 25 minus 21, which is 4. So that means our missing side here is 2. And we do need to make that a negative since we're going to the left of the origin. So sine of B we were given is negative square root of 21 over 5. And cosine of B is negative 2 over 5. And now we can put those into our equation. Cosine B, negative 2/5. Sine of B, negative square root of 21 over 5. Again, unlike the unit circle here, there's no great way to check your work. But do double check at this point if you were going to do when we do need to kind of baby step this because it is radicals. But after this next step, we should have a common denominator. So multiplying across, -1 times -2 is 2. 3 times 5 is 15. Our number in front of our 21, their square root of 21 is negative. So I have 2 times -1 is -2. And 2 times 21, that's going to go under our radical. It's 42. All over 15. And we do have that common denominator built in. So this ends up being 2 minus 2 radical 42 over 15. I don't think there's anything there that you can simplify. Awesome, that's number 5.